is like you want to understand what is recursion. So if you have looked something online, you would have definitely ended up with a definition that says recursion is a function that calls itself, or a recursive function calls itself. So if that's in your mind, well, that's correct up to an extent. But let me tell you a real life problem. Say if you imagine this definition, you would have something like this. Let's just say you have a function a that has nothing into it, and it just calls itself. Say a. So the main thing about this function is like what makes you think is if you write such a function, if you call it once, it would keep calling on itself, and you would end up with an infinite loop. So that's not what recursion is. And by the meaning we got from the definition, you pictured something like that. Even if you were to put this into a real life problem, say you were to peel an onion, you write a function that keeps peels the outer skin of the onion and again calls it and again peels the outer skin. So eventually you'll end up with like no onion, you just peeled everything. So that's not what we want. So without wasting any further time, let's get straight into the video and see what is recursion. So yeah, so here we are with the recursion definition that says a recursive function is a function that calls itself in addition to it until when you have to call the function. Like if you wrote a function a, you have to stop at some time. So that's the first condition that we have to add to a recursive function. And the second one is the logic, like what I need to do if I'm not stopping, what I need to do. You can't just straight away call the function. Say I called a function a and straight away again if I'm not stopping, I just call it. So that doesn't make any sense. You have to keep something that like a logic that that results in either the function being called or the condition being satisfied. So these were two things that we have added to the definition of recursion. And now our definition looks something like this. A recursive function is a function that calls itself until a certain condition is met. So that is recursion. Now, do you know what is recursion? Let's check a problem that we usually solve using recursion. But let's say it's a basic example of recursion in real-time action. So you might have come across this problem a lot. Factorial of a number. Well, by means like you could solve it using just a for loop. You just write for I like from I to n, whatever your number, like 1 to n, you have to find the factorial of n. So you go on multiplying 1 into 2 into 3 into 4. You could do it in a for loop, but we have a better way. And let's see why it is a better way. So just write definition of function fact. So by fact we mean factorial. We give it an argument n or parameter, whatever you call it, and then like n is the number we want to find the factorial of. So according to our definition, we need to have a condition that would tell to stop. Okay, so we have a condition, if condition, that says if n is equal to 0 or n is equal to 1, then what you need to do is just return the number 1, because we know the factorial of 0 or 1 is 1. So we just need to do it. We don't need to call the function again for this thing. We already know the answer to this. And for the rest of the part, like when you call the function itself, what you have to do is put the main logic which gives you the answer of the problem. So what the answer of the problem is, say you have to find the factorial of n. So what you do is the number n is multiplied by the number n minus 1. Similarly, n minus 1 is multiplied by n minus 2. So what you have to write is just n multiplied by n minus 1. So you just put it in the brackets, parentheses. So like it's a good practice. So that's it. It's how simple a recursive function looks like. It makes your code a lot more easier to read, and like it looks great. Like only in 3-4 lines of code we are done with the factorial of a number. Now to see the function in action, you just do print the number, like print the result. X is the number we took the input for, like the number we have to find factorial. And now we have to do just fact of x here. So that's it. Let's see a function in action. Here. We give it a number, say we know the factorial of 3 is 6. Yes, we get 6. Similarly, we know the factorial of 5 is 20. That's good. 5 into 4 is 20. Okay, we missed something here. That's why that's what I realized when you get 5. We just missed to type factorial. We didn't call the function actually. So if you type factorial, you can now see the correct answer. Something more. Okay, yeah, we just typed an extra. That was it for recursion. It was really easy to find problem. And if you like the video, please make sure you like and subscribe to the channel. So that was basically it. We'll meet again with a new problem next time. Until then, bye. Stay safe.